Okay, so here's your tutorial. Expertly done, because seriously, I have my iPad propped up on a couple of boots on my bed. Yeah. Anyway, okay, so... Sorry. Alright, so here's 21, 27, and 46, because I didn't know which ones you needed. So with 21, that's a plus right there, just in case you couldn't tell. Yeah, so with 21, both of these have tangents. This one's just by itself, the loner tangent. There are 4 of them here, so I subtracted a tangent. And then divide both by 3, because that's a GCF thing. And you've got tangent equals 1. And then at that point, your theta ends up being pi over 4 and 5 pi over 4. So really, when you're looking at these equations, you just want to look at them as if instead of, tangent theta or cosine theta or sine theta as just linear or quadratic equations. So you could do the same thing replacing all of these with x. So 4x equals 3 plus x. And then you can really just do the same thing from there. You've got your minus x. That's 3x equals 3 divided by 3, x equals 1. And then just remember to replace it with what it actually is. And to figure that out, because it asked for it in radians. And remember that there can be multiple answers depending on what your theta is. And please feel free to send me any questions you have about this. Okay, so then there's 27, and 27 is nice because it's already factored for you. If you need help with just factoring in general, let me know. Yeah, but this one's 27, okay? And so then, when you have them in the parentheses here, you really just need to set them equal to 0. It's pretty much as simple as that. So you've got cosine theta is equal to 0, and then cosine theta plus 1 is equal to 0. And then you can just solve it from there. So then this cosine ends up being, well, whenever x is at 0, which is pi over 2 and 3 pi over 2, I think, yeah. And then minus 1 cosine theta equals negative 1. And so then you've got pi. Yeah, so there you go. Those are your answers for that one. And then, let me adjust my boots here. Seriously, boot stand. Best stand in the world. Okay, so then here's sine squared theta minus 1 equals cosine squared theta. So there are 2 ways of doing this. My way made a little more sense to me, but Mr. Tom Berry's way is a lot quicker. So this one, I just looked at my identities, and cosine squared theta is 1 minus sine squared theta. So there's sine squared theta minus 1 is equal to 1 minus sine squared theta, right? Yeah. I'm checking my work to make sure I'm doing the right thing. Shh, don't judge. So then I wanted to get rid of this sine squared theta, which really, I think you could do the same thing with this one and get the same answer, as long as you, made sure that you stayed on track. Yeah, so plus sine squared theta plus sine squared theta, and then you get negative, or 2 sine squared theta minus 1 is equal to 1. Then you do your plus 1, and again, just going at it like it's, one of these kinds of equations, which we've been doing for a couple years now, so hopefully that comes easier. Sine squared theta equals 2, and you just over 2 sine, I'll move that for you, squared theta equals 1. And so then just figure out where y equals 1, which is pi over 2. There's your answer. So the way Mr. Tomberry did it, which is definitely faster, is here you've got here sine squared theta minus 1 equals cosine squared theta. So he realized that since the identity for sine squared theta minus 1 is 1 1 minus sine squared theta. If you were to rewrite this, then it would be negative 1 plus sine squared theta, and that these two are negative of each other. So if you multiply this by negative 1, and I know this is, I just don't know what you do and don't know, so I'm just trying to explain everything. Then you get negative 1 plus sine squared theta. And then you get your identity here. So this here ends up just being negative cosine squared theta equals cosine squared theta. And then you can go and just continue on from there. So hopefully that makes sense to you. If you need help with anything else, let me know. If it just doesn't make sense to you, let me know. I'm sorry it's so late, but I came home late. God, Ashley.